So this section is conservative vector fields. So what does it mean for a vector field F to be conservative? Well, it means F comes from taking gradient of some we call potential function phi. So we know gradient, to get gradient, we take derivative. So to go back, we need to integrate. So if we want to go from, so if we're given an f and we want to find if there's any phi, we should try integrating. So keep that in mind while we do the following problem. Okay, so this problem, it's asking, is this vector field F, is this conservative on R star? So this R star, we kind of just mean, in the xy plane, but we take away the origin. And the only reason we take away the origin is because x and y in the denominator, it shouldn't be 0. Okay, so we learned about the test for an f to be conservative, which so maybe it's helpful for me to write this f this way. So x over this, y over this. Right? And I think in the test we say this component is f, we call this component g, and the test is that if fy is equal to gx, then f is conservative. Right? So we only need to check that. So you might ask, why the first derivative is with respect to y, not x? The reason is because, remember, if f is conservative, then it's the gradient of some phi, right? So which means this thing should be phi x, and this thing should be phi y. So then, if that's true, then if I keep taking derivative one more time, if I take derivative of this with respect to y and derivative of this with respect to x, then we learned before that these should be equal, right? If you start with the same phi and then you take a second derivative but different order, this is x, first x then y, this is first y then x, these should be equal. So that's why in the test, the first component is taking derivative with respect to y, and the second component is taking derivative with respect to x. So be careful with that. So okay, so let's check this, right? So fy is so actually this is I kind of want you to do it by yourself. It's definitely non-trivial, but it's kind of tedious to show here. So I'm just going to tell you fy and gx, they're both equal to negative xy x squared y squared to the power negative 3/2. So you have several ways to, I guess 2 ways. One is using, these are just taking derivatives, right? So one way is to use quotient rule. The other way would be to use the product rule. So you can think of the divide as multiplying by the reciprocal. And then you can use the product rule. But I would say maybe the quotient rule is easier. So definitely check this. Make sure you do get this expression. It's very important that you know how to do this. It's fair thing to ask on the test. So since we check that this is true, so we conclude that f is conservative. So this is kind of the test, right? Test for an f to be conservative, and in this example we check that it is conservative. Okay, so the question also asked if it's conservative, we want to determine the potential function of phi. So we want to know what phi is. So remember previously I said to find out this phi, we should integrate, right? And the way we integrate is, so suppose f is the gradient of phi, then to go back, we should integrate the two components with respect to, so the first component now, it should be with respect to x. Why? Because, well, this is the first component, we want it to be phi x, right? So from phi x to phi, we integrate with respect to x. That's why this is dx. So again, this is kind of confusing. Like how do you integrate this? But remember, sometimes you have to kind of test something, right? So for example, we have a power 1/2 in the denominator, so that's power -1/2, which means if you integrate, the original thing will probably be a positive power 1/2. So let's try this, right? So once you write down this, you can then check by taking derivative of this and see if it's equal to the integrand here. And it is there. So our initial guess, you don't have to adjust anything in front, things like a coefficient. So this is correct. But one more thing is that it's not just that. You have to, because you're integrating with respect to x, so it's possible that you have the original thing have some, well, I probably shouldn't use this g because the g is already used. Let's say maybe g1, just to kind of make sure this g has nothing to do with this g. This is just some unknown function that only involves the variable y. This is allowed here because we're integrating with respect to x. So anything about y will be seen as a constant after you take derivative. Right? So it's allowed to have something depending on y here. And then, for the second component, we want to integrate with respect to y. So y, so it's also equal to that. And the same reason you want to, there's some, it's allowed to have some function here that only depend on x because the integration is respect to y. So anything about x is allowed here because once you take a derivative, it's gone. So now the question you ask yourself is there any chance for these two things to be equal? It's possible, right? So if we just let the g1 and h both to be 0, then certainly these two things are equal, right? So that is gonna be our phi. So then we can make a conclusion and say hence phi equals x squared y squared square root is a potential function. And is a potential function for f. And one small thing is that I said a potential function, which means you can maybe add a constant. It doesn't really matter. It still works, right? So I said a potential function. So hope that this is helpful. And then let's do an exercise. So the exercise also asks you, is this f conservative, right? So, and then we use the test. So the test, we call this first component f, second component g. And so the test is whether fy is equal to gx. That's the test, right? So then we just compute, Fy is equal to Fy is equal to, so this with respect to y, with y is negative x, and then gx is x. And then we see that these are not equal, right? These are not equal. So that means f is not conservative. So if it's not conservative, there is no point of computing. We don't have to go through the trouble integrating things to find the phi. So we know such a phi definitely does not exist. So this test is this test should be done like before you actually integrating the components, because sometimes it's quick, right? It's quick to determine if something is not conservative. So definitely do this test before you start taking, before you're integrating. Okay.